solution is here. And we are continuing with calculus. We're going to look at the derivative and use the derivative to interpret. I don't know how to say interpret. Interpret. Thank you, Eugene. Interpret graphs. Basically, by looking at the derivative, we'll be able to predict the shapes of graph and the other way around. So, when we look at the curve, okay, a graph of a curve, it could be, some kind of curve, f of x, okay? It can either go up like this, or up like that, it's going up, or it can go down, okay? Go down like this, go down like that. Now, if I look at a specific point here, x equal a, and I calculate the derivative, what do you think the derivative will be here? I'm not looking for a number, obviously you don't know what the number. What I'm asking is it positive, negative, or zero?
It's more than 0.
In other words, it's positive, isn't it? It's more than 0. Because the derivative is really the gradient, isn't it? So if the graph is going up, that means the derivative at this specific point, at x equal a, is positive. Does that make sense? Okay? And what about here? What is the derivative here going to be like?
It's also going to be
It's also going to be positive. It's a different kind of graph. There is a difference here. We're going to talk about this difference next lesson, not this one. But in this case, the first derivative is above 0, is negative. Okay? Where if we look here, what will be the derivative in these 2 points? It will be negative. It will be less than 0. Okay? Because the graph is going down. Okay? That's pretty easy. Okay? But what about... should have put me some more space. Let's see if I can write down. What if I have a situation where the graph is doing something like this?
Okay, but where's the tangent?
What would be the derivative at this point?
Maybe a. Oh, it would be equal to. Because it's at point A.
Let me help you. Will it be at this specific point? I'll help you by drawing the tangent.
0. Oh yeah, true.
Who said that?
Oh, 0.
Okay. Yeah, so I'm looking at specifically at that point. It's definitely not positive because it's not going up. It's definitely not negative, it's not going down. It's horizontal. And we know the tangent of a horizontal graph, or horizontal tangent means the derivative is 0. Okay? So at this point, I've got another one of those. It could be something like this, right? Okay? At this point also, we draw a tangent. Okay? The derivative is also 0. Okay? Now, these places, let me just make sure I'm using the right, yeah. So when the derivative is 0, okay, when the derivative of 0, we call these points, they're very special, very, very important point. We call them stationary points. Stationary points. Okay? They are very, very important for us. Okay, I'll pause here. Guys, so one thing I forgot to mention. I know that the derivative here, maybe you can tell me, the derivative here is what? Is negative. What we also say, which you know from way back grade 9, we also say that f is decreasing. You can say that f is decreasing at x equal a. It's going down, isn't it? Okay, where in this case, what happens to f here?
It's increasing.
It's increasing at a. Increasing at a. Now, what happens in the stationary point? What happens to f here? Let's start by f here. Is it increasing, decreasing?
It's constant. Decreases towards a.
Yes. And the way we say it, you're absolutely right, Eugene. We will say f is decreasing and then increasing. Okay, I'll explain. Okay? I just want to make sure, yeah. So, what does it mean? Before, as we get to A, it's decreasing. But straight away, a millisecond after A, it's increasing. So we say, I just want to make sure I got it right, it's both, we can, basically they use the words both, okay? It's both decreasing and increasing, both. Both decreasing and increasing, okay? Where if I want to look at this, what is F doing? It's both increasing and decreasing. Okay? So the order is slightly different. But Finn, you're absolutely right that strictly speaking, at the point x equal a, it's not increasing or decreasing. That's the definition of stationary point. That's what we call stationary point. It's like stationary. It doesn't.
It's basically equal.
It's not equal. It doesn't change. Stationary. But in the book, they want you to say that, so I'm saying it, and we can kind of understand. A millisecond before it's decreasing, a millisecond after increasing. Are we happy with that? Okay. I'll pause. So JD asked some question. I don't know if you heard him. He said, "Sir, okay, stationary points. I get that. The derivative is 0. Didn't we call these things turning points before? Okay, and you're right. Okay, these two things are also called turning points. Okay, but there are other stationary points which are not turning points. Okay, and here's an example. That is also, it looks like a tan. Yeah, it is the tan. Tan is an example. Good. Okay, right? So that is also a stationary point. Okay, what is actually the definition of a stationary point? Is that the derivative at that point must be 0. That's the definition of a stationary point. In a stationary point, the derivative of 0. And you can see that if I was to draw a tangent here, the derivative of it is 0. So the derivative here is also 0. That's a stationary point. But why is it not a turning point? What was a turning point? What was it? We spoke about turning points in parabola, right? They were like maximums and minimums. You can see this is not a maximum minimum. Okay? So it's a stationary point, derivative is 0, but it's not a turning point. Okay? Now, if I call this both decreasing and then increasing, okay, what do we call that? And I'm going to use the same word that they're using.
Interval.
Okay?
Increasing and increasing.
Yes! It sounds stupid, but that's how we call it. And I'll just use the same as I don't know if they have a certain way of like I've decreased before and after. It's basically increases before and after a. After x equals a. So it increases before, then suddenly it's like stopped, stationary, and then increases after. Okay? Can you think about a way, if we have an increasing before and after, can we have a decreasing before and after? Yes, show me with your hands. Draw a curve. That's it, okay? So Taylor got it. Something, oh, no, sorry. Okay? So we're going to have down, whoop, something like that. Alright? So we have x equal a. We have decreasing here, and it's decreasing then, so decreasing before and after. Okay? I'll pause here. I think we've got enough tools to solve some problems. Chaps, yeah, we are. So, in a couple lesson time, we're going to start exploring, investigating with a lot of details, cubic functions. Cubic functions, or cubic polynomials function is with the x cubed. And remember we did some work on factorizing and all that, which I said it's not as important. Now this is going to be important, but it's not easy. So I'm still preparing us. We're building certain tools. So we have a polynomial function, okay, and it's drawn like this. This is the shape. I already, I think, spoke about it. This is a typical shape of a cubic function. Okay? What they're asking us at this point, it's still easy. Today's lesson is easy. All we need to do is say, is if increasing or decreasing, or both increasing or increasing and decreasing after, like what we just said that, in those points, x equal -2, x equal 0, and so on and so forth. So how do I know that? How do I know, because I don't know these numbers.
You just...
what do I have to divide? Well, if I don't know what to do in calculus, what do I do? Derivative. Find the derivative. Okay. So let's find the derivative. What is the derivative?
I would say
6x squared
6x squared minus 12. Okay. Now, at x equal -12, I want to know if it's increasing, decreasing, or maybe it's a stationary point, meaning it's increasing and decreasing. So I need to assess the derivative at x equal not a, sorry, at x equal minus 2. In other words, I substitute minus 2 where? In the derivative. So it's going to be 6 times minus 2 squared minus 6 minus 2 minus 12. And I'll just save us some time. What I'm getting is 24. Now, 24 is larger than 0. So what is happening there? What is happening to the f? Is it increasing or decreasing? Increasing. It's just increasing. Okay? As simple as that, guys. As simple as that.
So it's a positive number, it's increasing. If it's a negative, it's decreasing.
Yes.
And if it's 0,
If it's 0, well, let's see.
Decreasing.
Yeah, or is it decreasing, increasing? You know, we'll have to find out. We'll have to find it. Okay. Right, same thing we're going to do for x equals 0. I've got the derivative again. I don't need to calculate it, but now I sub x equals 0. So it's going to be, it's not, is it going to be 0? It's going to be minus 12. Can we just do it quickly? Because obviously we put 0 here, 0 here, that goes away. We got minus 12, that means it's smaller than 0, meaning the graph is decreasing. Yes. Pretty easy, I told you, today's lesson is pretty easy. Okay, same thing now for a negative. Okay, so we're going to find the derivative in minus 1 is going to be 6 times minus 1 squared minus 6 minus 1 minus 12. So that is 6 plus 6 minus 12. How much is that? 0. So when the derivative is 0, okay, we have what we call a stationary point. Let's write down a stationary point. And we know we have a stationary point. But is it increasing and then decreasing, or is it decreasing and then increasing?
Because
Increasing and then
Correct. Okay? So Taylor realized, look, from looking at the graph, there are 2 stationary points, isn't it? There's 2 stationary points. Okay? One is a maximum, one is a minimum. One is increasing and then decreasing, the other one is decreasing and then increasing. Now, because I'm looking at x equal minus 1, that obviously is this one. I hit that one. Okay? So that I'm just going to want to write it down so it's both increase. You know what? Yeah, they're not even caring about how to write it, but I'm going to be a bit more strict with you. We're going to say decreasing and decreasing before. How do you write it? Oh, yeah, you're right. You're right. So increasing before. So it's going to be increasing before. Increasing before. I'm not going to write it down. It's going to be increasing before and increasing after. Okay, that's how we're going to write. Increasing before the stationary point, decreasing after. Okay, right. Let's try that. Okay, I'm going to just cut it short for you because I think you got the deal. The derivative at 3 we get is 24. Okay, so I'll cut you, do a little shortcut here. If it's 24, what does that mean here? Increasing. And the derivative at 2 is equal to 0, which means it's the stationary point, so we are decreasing and afterwards increasing. It's pretty easy, isn't it? Okay, let's pause. Okay, so the question that I gave you now, they might look a little bit confusing, but actually they're extremely easy. And you might get a question like that, but it's like the easy marks. Most of the questions you're going to get are more on this level. So they give you another cubic function, okay? They drew the graph. Later on, you're going to have to figure out how to draw it yourself, but we've got another lesson or 2. And what we want to find the stationary point. I want to know the coordinates of these 2 points. And then there's another question after later. I'll read it, okay? So, as sometimes it happens, we have no idea what to do, but it is calculus. So what's the first thing I should do? Find the derivative. Okay, what's the derivative? 3x squared plus 12x minus 9. Okay. So I'm looking for the stationary point. I'm looking for the values of x where, yeah. So how would I do it? Erin, you want to tell me?
no, so I think there's supposed to be a minus in front of the x.
minus, you're right. Okay? Alright, so I'm going to put a minus there. Okay? Alright, so how would I find the stationary point? What do I know about the derivative at the stationary point? At 0. So this, you know, like I told you in calculus, if you don't know what to do, you calculate derivative. If you still don't know what to do, just say it's equal to 0. That's the next thing you can do. And it's half the time, or even 70% of the time, it's going to be the right thing to do. Okay? So you find the derivative. That will be 1 mark in a test. Okay? You find the derivative, and second thing, you make it 0. But hopefully you understand that at the stationary point, remember, the derivative of 0. In fact, I'm lucky, I still left it here. That's like the definition of a stationary point. Okay? So, derivative is equal to 0. Right? I know how to solve these things. Okay? That's a quadratic equation. You can put your calculator, you can use a calculator, no problem. Okay? At this point, grade 12, I'm not asking you to do factorization and all that stuff. Just use the ABC. You know what I'm talking about, right? And I'll give you straight away the answers. Okay? I'll just show it quickly. It's actually easily. I will divide everything by -3. So x squared minus 4x plus 3 equal to 0. In other words, x equal -3 minus 1. Okay, equal to 0. In other words, x equal 3 or x equal 1. Why am I getting 2 answers? Because there's 2 stationary points. Aha! Okay? Now, alright. So obviously that's the 1 and this is the 3. Okay? And how do we get the y's? Substitute where? The derivative or the function? In the function. Well, if you do, let's put it in the derivative. If I put 1 here, I'm going to guess -3 plus 12, which is 9, minus 9. It's going to be, it has to be 0 because the derivative, the value of the derivative is 0. That's why it's a stationary point. Right? So it's not, I'm not going to put it in the derivative, I'm going to put it in the function because I want the y value, not the gradient. Okay? Right, I'm going to again cut it a bit, and the answer was -1. So here here is y equal -1. Just want to make sure I've got it right. And here y is 3. In other words, y -1, 3 and 3. These are the 2 points. Okay? So I need to, this could be my answer. Okay? Best thing if you just write down 3, 3 and 1 minus 1. Okay? Alright, are we happy with that? Okay, now comes the second question, which is actually really easy. If you got that, that's the hard one. Next one is easy. When is f increasing and when is f decreasing? And when I say when, you need to give me a range for which values of x is the f increasing. Let's start with increasing, okay? When is f increasing? Increasing.
It's from 1 to 3.
From x equal 1 to x equal 3. So how do we write it? From x larger than 1 or smaller than 3. And, okay, who said excluding? I agree with you. I agree with you. It should be larger than 1, smaller than 3. Because at 1 and at 3, it's like horizontal. It's not changing. But it goes back to what they said before. They want us to include it because here it's decreasing and then increasing.
What?
Yeah, no. I'm not happy with that. Let me just pause here. Okay, I just pause. So just to summarize what we were just talking about, I agree with you, Eugene. I personally would not include the stationary points, but the book, and that's the people behind the exam, wants us to include it. They say, yes, the stationary point, even though it's not really changed, they say, we include them, okay? We'll play along, okay? When is it decreasing? Okay, so it's before this stationary point, it's decreasing, and after this stationary point. Now, you can write in a couple of ways. The way I would like to write it is x smaller or equal to 1, because we're including the stationary point, or x larger or equal to 3. So that to me is the most obvious way of writing it, okay? Smaller equal to 1 or larger equal to 3. But Eugene started saying the interval notation. I'm fine with that. Okay, so we're gonna have -∞ to 1, including the 1. Okay? or 3 to infinity. There's nothing wrong with that. You can use either notation. I'm just going to show everyone here. You guys saw it. I'm going to pause here. Have a lovely day.